Welcome everyone. Thanks for coming to this talk. So small introduction. I mean, you already gave me an introduction, but usual for me to start with an introduction. So my name is Deepu K Sasidharan. I'm the co-lead of JHipster. I'm also a Java champion, and I also created some, OSS tools like KDash for Kubernetes, JDL Studio, and stuff like that. I'm an open source aficionado and a polyglot developer. So I work as a developer advocate at Okta with a focus on DevOps. I also do a lot of Java, Rust, Go, JavaScript, TypeScript, and so on. I've written a book if you're interested in full stack development and stuff like that. Check that out. Follow me on Twitter if you're interested in content like these, and let's get started. So what is FFI, right? So a foreign function interface is the ability to call functions or routines written in one programming language from another programming language. So that's what it is. So this is generally used to access native functions or programs on your host OS. It could be written in a low-level language like C. So most languages, most modern languages, they provide some form of this feature out of the box. Now, the term originated from Common Lisp, but it's also known by different names in different languages. Like, for example, in Java, it's known as JNI so far. So most languages also use C++ calling conventions for FFI, and natively support calling C++ or assembly functions. So this is the commonality or what's common among languages when it comes to foreign function interfaces. So most of the use cases around, use cases for FFI were around interacting with legacy apps or accessing host OS features or working with native libraries. These were the use cases that we always used FFI for. If you're a Java developer, you might have used FFI to maybe access a random native library which is not available in Java, for example, maybe like a PDF creator, for example, which is not available in Java, or maybe to interface with some hardware, stuff like that. So you might have used a foreign function interface in the shape of JNI. But recently, with the surge of machine learning and advanced arithmetics and stuff like that, so FFI has become way more important. It has outgrown that use case arena of legacy apps and accessing host OS. It has gone from there, and today FFI is far more important when it comes to machine learning and data science, because you can do GPU CPU offloading. For example, you can work with applications like CUDA, OpenCL, OpenGL, Vulkan, DirectX, and so on. And if you want to work with these kind of technologies, you need something like FFI. There is also, of course, we still have the use case of interacting with legacy applications or writing something in a language other than Java, for example, when it comes to Java, and also using native library. But to me, the most important features would be accessing CPU and GPU functionality. Multi-precision arithmetic and matrix multiplications, you would need FFI for those. Using TensorFlow or BLAS or something like deep learning related use cases. And of course, then there is also interfacing with stuff like OpenSSL or V8, or putting a Python interpreter in your program or stuff like that. There could be a lot of these use cases. I have used FFI a lot in my career so far. During the time when I was a consultant, we had a lot of use cases for FFI in the legacy applications or accessing host OS kind of thing. Like, for example, using some sort of some advanced PDF creators, for example, or to interface with applications that were running in mainframe and stuff like that. There was also use cases where we had Python interpreter embedded and stuff like that. So there's always some use cases. And given that our industry is going towards more of data engineering, machine learning, and stuff like that, this becomes more and more necessary. And if a language has good support for FFI, then you could you don't have to worry about choosing that language to do whatever use case you have. And if you see in the future, you would you would do some sort of data engineering within your application, then you could still be worry free about choosing a language like Java, for example. If it has good FFI, then you can choose Java and be sure that, okay, whenever I need to hit that point where I have to do machine learning, if I have to do some GPU offloading, then I could still do it with Java. You don't have to switch your stack just because of these things when you have a language with good FFI support. So that's an important aspect. So before we delve into the current state of FFI in Java, I think it's important to look at a brief history of FFI in Java. Right. So for a long time, even today, the standard for FFI in Java has been Java native interfaces, or JNI. And it is notorious for being slow and insecure. If you're used to other languages like Rust, Go, or Python, you probably know how easy and intuitive it is to use FFI in them. And that as Java developers, that leaves something to be desired. So even to do a small native call using JNI, you have to do a lot of work, and it could still go wrong, and it could still end up being a security issue for that when you use JNI. So that's the biggest downside of JNI. And another issue with JNI is the complexity to use it, and also the need to write C bridging code manually. So these issues can lead to unsafe code. Of course, if you have worked with C code, you know what I'm talking about. Whenever you have to write C code, you always have to worry about ending up with some security holes, because you might be writing unsafe code. This can also cause performance overhead. So the performance and memory safety of JNI code 100% depends on the developer who is writing it, and hence the reliability is going to vary. So if you're an expert C developer who is writing Java code, which is rare, then you might have good JNI implementations. Otherwise, the mileage would vary. So in my opinion, it's high time for the Java world to move away from JNI. But unfortunately, it's still the standard. We are getting there, but not there yet. So we'll see why. So the complexity of JNI also gave rise to some community-driven libraries that made it simpler to do FFI. So Java native access is one of them. It is built on top of JNI, but at least it makes FFI easier to use. Especially it removes the need to write any C bridging code manually and reduces the chances of memory safety issues. But it still has some disadvantages of being JNI based, and it's slightly slower than JNI for many use cases. However, it's also widely used, battle tested, and definitely a better option than hand coding, JNI. So it's still a better option. There is also another popular library called Java Native Runtime, or JNR. So though it is not as widely used as JNA or not as mature as JNA, it is much more modern than JNA and has better performance than JNA for a lot of use cases. It is also based on JNA underneath. All of these are based on JNA underneath. It just removes the need for you to manually write the bridging code and stuff like that, gives standard APIs and stuff. So these are still better option than writing JNA yourself. But sometimes they may not perform as good as JNI, but JNA is supposed to be having better performance and more modern. So these are alternatives. If you're currently having JNI kind of use cases, then these are the alternatives I would suggest, JNA or JNR, until we get to Panama APIs. And so finally, the last piece of the puzzle would be the Project Panama. So Project Panama is the latest Java project aiming to simplify and improve FFI in the Java world. And as part of this, many proposals are currently being incubated. So let's take a look at some of the active proposals and how they will work, and let's see if finally we are getting there or not. So the first piece of the puzzle is the Foreign Memory Access API. So this was first incubated in JDK 14. And after 3 incubations, there's a new JEP that combines this into the Foreign Function and Memory API. So the goals of the Foreign Memory Access API are to be safe and efficient in accessing foreign memory outside of Java heap. That means consistent API for different types of memory. JVM memory safety should not be compromised. We'll come to that later. explicit memory deallocation. So these are also downsides of JNI currently. So these are also trying to address the downsides of JNI by having JVM memory safety, explicit memory deallocation, and also the ability to interact with different kinds of memory resources, including off-heap or native memory. So these are the goals of this particular API. So it had 3 incubators from Java JDK 14 until 16, and then it was combined as foreign function and memory API. And another essential part of Project Panama is the foreign linker API. This was first incubated in JDK 16 and was combined with the memory API that we saw earlier in JDK 17 to become the foreign function and memory API. So it also has similar goals, whereas the previous one was memory focused. This is foreign function focused. So again, the focus on ease of use, flexibility, and performance, of course. Initial support for C interop, ability to call native code in DLL.so or dilibs. Create native function pointer to Java method, which can be passed to code in a native library. So that means, so the overall goals also includes passing foreign function two-way. So as I mentioned, first incubated in JDK 16 and then combined into foreign function and memory API in JDK 17. We also have vector API. Normally, people might not realize that this is part of Project Panama, but vector API is also part of Project Panama, which is quite crucial for some use cases of FFI, especially in the machine learning and advanced mathematics arena. Again, it has similar goals: platform agnostic, clear, concise API, reliable runtime compilation and performance, and graceful degradation. These are the primary goals. It also was first incubated in JDK 16 and had 4 incubators until now. So the final incubator, hopefully the final incubator is in JDK 19. And finally, the combination of the memory and linker API, right? So finally, we have the foreign function and memory access API, which was the combination of those. So that means the goals of both those become the goals of this particular API. Ease of use, safety, performance, generality, and such. Again, first incubated in JDK 17, second incubator in JDK 18, and we are going to get the first preview in JDK 19. So it's in the preview state now, so that means it should be much more stable now, and hopefully we'll have this standardized by, I don't know, JDK 21, hopefully. So let's hope for that. So that should be like in a year, probably, year and a half. And finally, there is also a fantastic new tool called Jextract. Though it's not part of the JDK itself, it's bundled as part of the JDK as like JLinker or stuff like that. It is quite essential for Jextract. We'll see why. It's a simple command line tool. It generates Java API for a native C header. So you point a native C header with Jextract and run it, and it will extract. It will create a Java API for that entire header file. So that's basically it. So this is shipped with OpenJDK Panama builds for now. Hopefully, this will be shipped with JDK when Panama is standardized. This makes working with large C headers a cakewalk. So Jextract is not required, it's optional. You don't need it to use Panama APIs, you can do it manually. But when you start working with large header files, a lot of functions and stuff, then it becomes annoying to do them manually. So then Jextract kind of makes it easier and cuts down your work by more than half. That's the beauty of it. So since JNI is the current standard and Panama aims to replace it, it makes sense for us to compare those, right? So let's make some simple comparisons. So I think most of you would be familiar with the getpid function of the standard C header. In Linux, it is found as uni standard header. I don't know what it is called in Mac or in Windows. Predominantly Linux user, so not very familiar with names there. So I'm going to compare the getpid actually, because it's one of the simplest function you could find in the C header. As you can see here, so let's try using getpid with JNI. So as you can see here, there are precisely 6 steps to make this simple code using JNI. You start by writing a Java class that declares the native method that you're going to use. Then you use Java C to generate a header file and a C class for this. These are the native bindings. Next, you will have to implement the C class. And remember, these are Java developers we are talking about, needing to write C code. This means you must write memory safe C code, which has access to the entire JVM via the JNI-N variable. If you look at the signature of the generated C file, you have some variables being passed, right? And the first one being passed is a pointer called pointer to JNI-N, which is the entire memory of your JVM as a pointer. So imagine what you could do with this in this particular function, right? And this is C. So you have to manually take care of memory safety. So imagine having your entire JVM of your application, the memory of your JVM in a C function, and having to manually make sure that you're not having memory leaks or you're not causing a CV and stuff like that. So this is so much pressure on Java developers, I would say. Some might not even be realizing that, which probably will end up as a security issue in the future. But that is the kind of thing that we are talking about now. So as I was mentioning, so the entire JVM memory is passed as a pointer to the C class. In many scenarios, the developer may not have much experience with C, so that's going to be fun, or more like a security nightmare for who is going to audit this code, or for the security teams. Next, you'll have to compile the C code into a platform-specific dynamic library, depending on where you're going to deploy this, and determine where to place the binary. There are no like standards or anything for that. You basically try out and see if it works, right? Pray if you must, and then that all this works out without exposing the app to security vulnerability. That's the biggest concern here. Accidentally exposing your entire Java code, which is supposed to be memory safe, to a memory safety issue just because you wrote some JNI function, right? So you're throwing all that memory safety of Java out the window by doing this. Then you will load this into the Java class and compile, and hopefully this works, right? So this was just to do a getpid call. So imagine writing something like OpenGL interface or GPU offloading using JNI. It's going to be a nightmare, right? So I wouldn't even suggest doing any of that in Java. So if you have that kind of complex JNI use case, don't do it in Java for now. That would be my suggestion, because it's going to be horrible. Maybe just do it directly in C rather, right? So let's see how we could do the same using Panama. There are 2 ways to do this with Panama. So the first one on the left side would be doing it manually using the foreign the linker and the memory APIs. So it's like few lines of code. You get a instance for the linker, the new foreign linker API. You do a system lookup here, because since you are going to get it from the system, you get a down call handle for that particular function. That's it. Then you invoke that function. So that's basically it. It's simple as that. And if you want to do it even more simply, then there is Jextract. Then that's a second way. You point the header file, the C header file with the function. So in my case, this was the uni standard header. You point that with Jextract and you run the command. It's going to generate a Java API for that. It places in that particular folder and like package that you meant that you specify. It's going to put it there, and then from your Java code, you just use that similar to any other Java API. So that's it, right? So for simpler stuff, using Panama APIs directly should be fine. Like if you are just going to call 1 or 2 APIs, it's perfectly fine to do it manually using the linker directly. But if you're going to have more complex use cases where you're going to call a lot of functions from a header, then using Jextract is an easier way. Because technically Jextract also, if you look at the APIs generated by Jextract, it will look very similar to what you see on the left side. It will get the linker, it will do a system lookup, it will do the down call handle and all that. It will just do all that boilerplate for you. That's the difference. You don't have to write the boilerplate manually. If you want, you could also write it manually. So in my opinion, using Jextract is much more scalable. and simpler in the long run. But you could see the difference, right? So this is, regardless of what you use, this is this is 1 or 2 steps compared to JNI. And regardless of how complex your with JNI, the more complex your use case, the more complex the entire thing becomes. Whereas in with Panama, regardless of the complexity, it's almost the same process. Especially with Jextract, it's going to be the same process. Of course, there's going to be a bit more complexity when you start handling off-heap memory, and when you start doing passing memory between your C and Java and stuff like that. Gets a bit more complex, but still not as complex as how you do it in JNI. So I also ran some benchmarks to see performance of JNI and Panama, because for now, in standard Java, JNI is still the most performant way to do foreign functions. So I did some benchmark. Again, I used the getpid function because it's the simplest to see what's the performance difference. We'll call the API using JNI and Panama APIs and compare the performance. I also ran both Jextract and the manual version both. So for this, I ran it in 17 and 18, Java 17 and 18. But for this, I reran it in OpenJDK 19, since we have early access builds for Panama. And this is the result that I got in my machine. So Panama API seems slightly faster than JNI. And remember, we are only in the preview. No, currently we are in the incubator stage. We are not even in the preview stage yet. Preview would be in JDK 19, and in the OpenJDK 19 preview builds, I think it's probably very close to what you will get in the OpenJDK 19 preview itself. But I would assume whatever we have at this point is in between the incubator and the preview part, preview code, right? But even with that, the performance is actually slightly better than JNI, and I had the same result, similar result with JDK 17 and 19 as well. Sorry, 18 as well. Whereas I think in 17, the Panama calls were almost as fast as JNI, and in 18 they were slightly faster, and with 19 is the same. It's slightly faster than JNI. And for larger applications or like bigger use cases, you should see even more difference. So if you want to play around with the benchmark, I have it on GitHub. You can see the link here. You can go and look at the code or play around with it. Do your own experiments if you like. And I don't know if I mentioned, but let me. Yeah, so there is also this this series on Fuje. If you're not familiar with Fuje, it's kind of a Java community initiative. There are a lot of Java folks writing blogs there and stuff like that. So there is this series from called awesome guy and an expert in Project Panama. Check this out if you want to go get if you want more in-depth information about Panama, especially if you want to learn how to use Project Panama to do manipulate foreign memory, off-heap memory, do complex stuff like say for example run graphics using OpenGL, for example. These kind of things. He has some blog posts about that in the series, so they are really great. I would really recommend that. So check that out if you are interested. And yeah, we were talking about benchmarks. Yes. Yeah. So are we there yet, right? So that's the question now. So since we have OpenJDK 18 now, so for OpenJDK 18, Project Panama is still not production ready because it is still a preview build. That means the APIs are being broken for every release, so there's not going to be any warning about deprecations or you will see like breaking API. I mean, between 17 and 19, I had to whatever trials and stuff that I was doing. For example, I was trying to do some GPU stuff with this, and I had to rewrite the code like 10 times between versions. So there's going to be a lot of breakage as long as this is in the preview incubator stage. Preview stage should be a bit more stable. So after 19 should be a bit more stable, but still there's going to be something that will change. The APIs might change, things will break, things will be renamed and stuff like that until it gets stable. So not a good idea to use this for any production stuff, but we are getting there. So we can already use Project Panama for C interop. That means working with C, C++, Fortran, Rust, or any other language that can, that can create C headers. So you can use for that. I have personally tried running some Rust code with JNI. Works perfectly fine. Performance is on par with JNI. Hopefully this will be improved further because we are seeing slight increase every release. And Jextract is amazing too. It makes working with native libraries so easy. I mean, imagine if you are using OpenGL without Jextract. That's so many functions there. So Jextract with one command, it creates that API for you, and then you just need to know which methods to call. That's it. And it's definitely memory safe and less brittle than JNI. You also have native off memory access. You don't have to work with the entire JVM memory to have any memory access. You can do that in a much more safe and efficient way. Downside now is documentation. The documentation official sources are not great because they are still heavily outdated. So most documentation you would find for Project Panama in an official, Oracle docs or the Panama JDK docs, they're quite outdated. They probably refer to the whatever version there was in 15 or 16, and a lot of things have changed. So if you try example,
I have a question. I don't understand, or maybe you can explain, why is it more safe memorily compared to JNI? What's changed that make it safer?
So the main thing is, let's go back here. So this is a standard, on the left is a C function that would be generated when you do JNI, right? And you can see that JNI-N passed as a pointer. So that's your entire JVM memory. So you have access to entire JVM memory. So if you want to access anything in the Java memory, you would have to work with those. That means you're exposing that entire thing to that particular developer's C knowledge. And with C, you have to make sure of handling your, you have to allocate and deallocate memory manually. You have to make sure you're not leaking memory. You have to make sure you're not causing a buffer overflow or whatever. You have to take care of all that. So you're also putting your entire JVM memory, which is supposed to be memory safe, into this and making it memory unsafe. So now you can easily cause a security vulnerability. You say, for example, you wrote something that's going to cause a buffer overflow, something. You're creating a security loop over there, right? So that's with JNI. With Panama, you don't have this.
But the fact that you're running JNI code, you can buffer overrun anything that you want without access to the JNI-N, right? You can take a pointer and write anywhere that you want.
Sure. Again, with JNI, you can do that. But okay, my point is with JNI, you also are exposing your JVM memory, right? Which is supposed to be memory. If you're also exposing that here, you can do whatever you want with that. You can go manipulate the JVM memory and you can crash your application and cause other security. So again, basically, we can talk about possibilities there, endless possibilities there, right? The base problem is you're exposing your entire JVM memory and you're going to work with C code. That's the biggest problem. And we all know how unsafe C is. I would never write C code, right? Especially now with Rust, I would never even consider touching C unless that's like, there's no other way, So with Panama, you don't have this. You're not going to get your entire JVM as a pointer. You're not going to get that. With Panama, if you want to access memory, you have to use the foreign memory API, which has specific APIs to handle memory, handle off-heap memory and everything. And it is implemented in a much more safer way. It is less brittle. You don't have to work with, number one, you don't have to work with C anymore. You don't have to write any C code anymore. So that already reduces your memory safety footprint a lot, because you're going to work with Java. And since Java is memory safe, you're only going to get issues whatever Java. So of course you might still get a memory leak, but you probably are not going to cause a memory safety vulnerability. So that's the difference I'm talking about. And you could boil this down to just one thing: having to write C and having not having to write C. That's a huge difference in my opinion already. So that's the biggest difference in my opinion already. And that itself is enough for me to say this is like 1,000 times more memory safe than using JNI. So yeah, so I was, I think I was on, does that answer your question?
Yes, thanks.
So as I was mentioning, the documentation needs a lot of improvements. It's quite outdated. I think if you are going to refer most of project OpenJDK or the Oracle documents for this, you're going to get stuck at some point because they're outdated. The blog post that I mentioned earlier from Call on Fuje, they are much more up to date, I would say, at least until JDK 17. Things there was some changes in JDK 18, and probably there's some more in JDK 19, which would probably break some more. But again, these are all expected since it's an incubator feature or a preview feature, right? So this all should be fixed when it is out there. So these are some more material I would recommend if you are interested in learning more about this, or if you're interested in figuring out on trying to do something. There was a really nice example from someone about making a Java teacup using, I think it was using OpenGL with Project Panama. I was trying to recreate that, but yeah, I was stuck at some issues because of breaking codes and stuff. But Carl has a similar example in his blog, so do check that out if you're interested. So that's it, folks, and thanks for taking the time. You can reach out to me on Twitter if you have any questions later, or if you want to follow any of these. And thank you. If you have any questions, I will be happy to answer.
Thank you, Deepu. I have a question regarding the performance. It's something that I think the most thing that someone mentioned in the past regarding the JNI is that it's a bad performance if you're comparing it to other FFI in other languages like Python, Go, and Rust and Go. So
definitely,
as far as I understand, the Panama project need to solve it as well. It not looks like they are going to fix it. It looks like the same on par. It not looks like a better performance from that.
Yeah, for now, yes, it's slightly better than JNI, but again, we are still in the incubator stage, right? So I'm expecting this to improve, but I'm not going to expect this to improve tenfolds or something and become close to, say, FFI in Rust, for example. It's not going to get there, right? It's going to be better than JNI, but it's not going to be like on par with some other languages, because I think there are still some limitations when it comes to doing it in Java, in the JVM. So those are going to be there, but within Java, it's definitely going to be better than JNI, but it's not going to be as good as in Rust or some other languages. I don't think it's going to get there. Maybe with many more revisions of JVM, because every new revision of JVM is also getting better in terms of getting faster. So it will keep on improving, but at least for the first revision, the first stable revision, it's the aim is to I think at least get same performance as JNI, because one of the main goals of Project Panama is actually not performance. It's to get rid of all that memory safety issues and brittleness of JNI. So that's the main goal, I think. So I think it will improve, but it's not going to, if you compare it with Rust or something like that, it's not going to get there.
Thank you.
I have a question. Hi. So regarding working with Rust code, you've talked about working with C header files. So with Rust, you would kind of export it into a C header file and use Jextract, or would you do it with DLL?
No, exactly. Because regardless, not just Rust, with any language. So Project Panama aims to work with C interop, right? So any language that has C interop can work. That's the thing, and I think in most languages that's the standard way. Most languages that support FFI, they just support C interop. The C interop is still the common part, right? So other languages that also support C interop, you export your go to C header files, and then you use them. So that's the way. Yes.
Okay, thanks.
Deepu, I have a question regarding other motivation about where you see such use cases, other use cases that you mentioned. You mentioned a few OpenGL and TensorFlow, but did you had the chance to put your hand on one of them and said this is works good, this is works bad, or because calling in a different function in other libraries, I can think in a lot of different use cases to do it, but I think what interesting is that production grade stuff, if someone use a TensorFlow or OpenGL, like you mentioned, but in the real world projects, yeah.
So yeah, so I of course have tried. So for example, I tried OpenGL stuff, but for my own experiments and stuff. So I won't say it's the production thingy. But I think the biggest use cases would be for existing applications, existing code bases, that is, or existing Java shops, right? So if you have a company which is predominantly Java, and you want to take advantages of, say, CPU or GPU offloading, or if you're getting into machine learning and you want to take a lot of GPU offloading, right? Then you don't have to worry about, starting a new stack or like rewriting your application into some other language. You don't have to worry about that. You can use Panama, and you can do that now. Of course, the performance might take a hit here and there depending on what you're trying to achieve. But if you are going to let everything, if you only care about the end result, then you actually don't have to worry too much about that, because you're just going to offload that, right, to a GPU or something. It's still going to be better than doing it in Java directly. Same for vector computations and stuff like that. Offloading is still going to be better performing than doing it in Java. So for existing companies that have existing applications where they want to take advantage of these things, it is still good. And unfortunately, most of these kind of applications, like they're still written in C, C++, or like some sort of native code. So not every company wants to directly embed or work with that. So they all prefer a high-level language, and whenever they do this, they kind of do the same. They do the offloading. So it just makes Java also a suitable language to do the same, especially for existing companies who cannot think of migrating and stuff. So that's the number one thing. Of course, I won't say so for example, if you are doing OpenGL, like I was trying some stuff, and you don't see any sort of, like, for example, if you're rendering something using OpenGL from Java using Panama, I mean, it just renders fine, and like you don't see lags or stuff like that. So if you are building games, for example, in Java, so it could be a good use case to do the rendering with OpenGL instead, right? So it's still going to look much better than trying to do it in pure Java. So there will be a lot of use cases, especially given that Java is such a proliferated language with so many people using it, and yeah, Java still has a great future, even with all these new languages, with Rust, Go, or whatever. Java still has a huge future, and it has a huge market share with like a huge developer base. So it's going to be there for a while, right? So there is going to be use cases, and there is going to be instances when you want it. I mean, there are currently people who want this, but they cannot do it because they don't want to go through JNI. So for them, this is going to be an alternative. So it is also about keeping up with the other languages, for example, that is coming up with new features, keeping up and making sure that all these new use cases, especially given that our entire industry is going towards data science, like everyone is doing that these days, and it's going to be the future. So data science and like machine learning is going to be the future. Everyone is going to start doing machine learning. Even small companies are going to do machine learning once it becomes more and more approachable and more easier. So at that point, you would want every advantage you need, and being on the Java stack shouldn't be an exception to that. So that's also one thing.
Regarding the payload size, did you have the chance to check the benchmark? Because I saw in the past things that if you want to back and forth payload, a very big payload. So for instance, if you have a function that got, for instance, a phone number, and then doing some lookup in some C code, doing some translation or something like that, and you have now millions of phones, and you don't want to do this kind of iteration between the Java and C. So you want to transfer kind of millions of numbers into the C, in kind of a map, and then doing it a one, and then return back a one result. So did you? I remember there is a lot of pain in a big payloads in and in a big payloads out from a performance perspective. Did you know if they...
No, I haven't specifically tried that, but from the discussions I had with other folks, I think there are still some things that especially when it comes to the foreign memory part of this API, there are still some things that are being worked on, and that again, that's why this is still an incubator and just getting into preview. So I think there are still going to be some issues that needs to be ironed out. I personally haven't tried that, so I cannot comment on if it is better or worse than JNI. I mean, given how the foreign memory API is shaping up, I don't think that will be a huge problem. At least when it becomes stable, I don't think that will be a huge problem. It might be slightly slower than doing it in JNI. Again, we can only compare with JNI. That's another problem. So it might be slightly slower than JNI, but I think it will catch up. But then again, not everyone is going to do that all the time. So that these are kind of edge cases. Of course, there's always going to be edge cases that here and there, that where JNA might perform better and stuff. I mean, even within JNA, like JNA and JNR and JNI, you can find edge cases where one performs better than the other and stuff. So that's always going to be there. So I don't think that will go away anyway. But it seems it will get there. I mean, it's going in a good direction, in my opinion.
Okay, thanks. Anyone else? Questions? Okay, so sounds very good. Thank you very much, Deepu, about your time and your session. It was very interesting. And I hope to host you for a different topic in the future.